We're going to work through a titration problem together. Our homeschool group can't meet today due to widespread illness, so I want to work through one problem for any students who haven't quite finished up on their Module 10 work yet. This is from Apologia's chemistry book. It's the old 2nd edition, Module 10, extra practice problem number 11. So what you're looking at here is a situation where 3.51 milliliters of the hydrochloric acid neutralized 50 milliliters of the magnesium hydroxide. Hopefully you're realizing there's a problem with this right away. We can't compare volumes like this. Unless we're dealing with gases and applying Gay-Lussac's law, we do not balance equations based on volume. What we do balance them on is number of moles. So we're going to have to figure out a way to know how many moles of hydrochloric acid and magnesium hydroxide we're working with. If you remember, when we have hydroxide or OH in the base, we typically get to work with acid plus base yields salt plus water. This is going to make things a little easier because we know what we're starting with and we know where we're heading, and we can get the equation without too much trouble. So we can tell from the wording of the problem that the acid is the 1 molarity HCl, even if you didn't recognize that as hydrochloric acid. That means the base must be the magnesium hydroxide. Hydrogen would have a +1 charge, chlorine -1. So those balance. Magnesium has a +2 charge, so that's why we have two hydroxides which each have a -1 charge. If you don't recognize the term hydroxide, please go ahead and review on page 288, the chart of common ions. You need to know those, and you definitely need to know hydroxide. You see that all the time. So we know our equation is going to yield water. The H's from the acid and the OH's from the base will give us H2O. What's left over is the magnesium from the base and the chlorine from the acid. We know that element's going to have magnesium and chlorine in it, but we need to balance it correctly. Magnesium is in column 2, so that's a +2 charge. Chlorine is going to be -1 charge. So to balance it, we're going to need 2 chlorines. Each water molecule is formed by taking one H+ from the acid and one OH- from the base. Notice that there are 2 OH- in each base, and only one H+ in each acid. That means we need twice as much of the acid as we do of the base. So we'll put a 2 as the coefficient in front of our HCl. At this point, if you count up all your atoms, everything is balanced, so we don't need to change any more coefficients. Now that we have a balanced equation, we can tell that we're going to use 2 moles of hydrochloric acid for every 1 mole of magnesium hydroxide. Let's review where we are in the problem right now. We just figured out that we need 2 moles of HCl for every 1 mole of MgOH2. We know that we have a 1 molarity solution of HCl and that we use 3.51 milliliters of that acid. That's everything we know about the HCl, and we can use that with our molarity equation to figure out a little more. We know molarity is number of moles over number of liters. I have a slight preference to go ahead and rearrange equations before I plug numbers in, so I'm going to multiply both sides by number of liters to determine that number of moles is equal to molarity times number of liters. Plugging in my values, 1.00 molarity and 3.51 milliliters. Please notice I converted that to liters because that's what molarity is defined as. And that gives us 0.00351 moles of HCl. So now I know that I have 0.00351 moles of HCl. I know there's a 2-to-1 ratio, but it might be confusing. Do I double it or do I cut it in half? If you can figure it out in your head, that's fine, but you can always go the tried and true way. Whenever we do any conversions, we just take what we're working with and we multiply it by a fraction equal to 1. We're going to set up that fraction equal to 1 so that the bottom lets us cancel out the units we don't want to keep, and the top brings in the units we want to end up with. In this case, we're putting 1 mole of magnesium hydroxide on top and 2 moles of HCl on bottom. Since those are equivalent, this fraction is equal to 1, we are not changing our value at all. You do the math and you get 0.00176 moles magnesium hydroxide. So let's take a minute to look big picture again. We are now moving into the magnesium hydroxide calculations. We were told that we used 50 milliliters at an unknown concentration. We want to find that concentration, and we just figured out how many moles of it we have, which is 0.00176 moles. So we do know milliliters and we do know moles. We can use our molarity equation to figure out concentration. Plugging in our values, we have 0.00176 moles of magnesium hydroxide. We also have 0.05 liters. Notice that I converted that from milliliters. We must work with liters for molarity. And that gives us a final answer of molarity of magnesium hydroxide of 0.0352.